First things first, we need to talk about normalization. Normalization is essentially organizing your database and making sure it does not violate any rules. Dr. Gogling defined three main rules that we need to follow when we do a normalized database structure. These three main rules are atomic data, no redundant data, and everything depends on a key. Atomic data essentially means everything is broken up into the smallest structure or form in the table. As we can see here, this is a bad example, as the worker has worker ID, which is fine, it's the primary key. But then we have name and job. Well, you have a first and last name, so that could be conflicts. And then job can also be split. Over here, we have a more normalized structure between the worker, between the bad worker, unnormalized structure, and the normalized. On the normalized side, you can see that in the worker table, instead of name and job, it's name ID and job ID. The name ID refers to the name table, which has first name, middle name, and last name. The job ID refers to the job table because a worker's job could have multiple departments in a job name instead of just a job. So by breaking things into atomic data, it allows both these to be more descriptive and just allow it more structured and less conflicts to happen. The second character of normalization is no redundant data. Above, you see these two tables. This is a violation of normalization because they both have redundant data. In the product table, it has P name and P description, or product name and product description. If you go into the store table, we have product name. They're both in both tables. That is redundant data. We do not want that. Then we also have sale ID, product ID referring to the product table, and employee ID. But still, they have redundant data, and this is not good. The final attribute of normalization is everything depends on a key. The top ones are violation. As we can see, we have two tables, school and students. School has student ID, type ID, and location ID tables. But for this, we're just going to use the student ID table. So in the students table, we have student ID, first name, last name, and school name. But what does school name have to do with the student? It doesn't. That is data that is not depending on this key. So it would need to be moved into a different table or just inside the school main one. As we can see down here in the more normalized structure, our original table now includes school name underneath school instead of student, and student is just first and last name. This is an example of more normalized structure where everything depends on the key. All of these depend on this school ID. All of these, just first and last name, depend solely on the student ID. Now for this assignment, we are also tasked to create a normalized database based off the bikes that we did in class and copy it over. So I have done that here, following all the things we wrote up in class and continued to copy off Kyle's as we're going to develop this over the semester. I have also attached this in the assignments, underneath the assignment, so you can actually view the file in the full section. But as you can see, we have the bike table, the type, brand, registration, material, color, and owner, and then two bridge tables of bike owner and bike color that are all tied back to the bike table.